The following review has been made for College Prep Math.
Hey y'all, welcome back. Today we are preparing for our College Prep Math final exam. We're going to be reviewing several concepts here, including solving equations. We're going to look at graphing lines, solving inequalities, factoring quadratics, and more. So this review was designed by ACC to give you a pretty good idea about what is going to be on the test. I have seen the test, and I can assure you that if you're comfortable with all the problems that are on this review, you will be in very good shape for that exam. Now, the exam is going to be shorter than this review. The actual test is going to be about half this length. One thing that you should know is that the final exam is not going to be multiple choice like most of the tests that we've taken this year. So just keep that in mind as you work through, especially these solving equation problems. You do need to show your steps if you want to get full credit. So practice makes perfect here. Make sure that you're showing your work as you go through these problems. Something else that I want to throw out there too, I know many of you have already taken and passed the TSIA2 exam, and so this may not apply to you, and you may be going to a college other than ACC next year, in which case this also would not apply to you. But if you happen to have not passed the TSIA2 yet and are going to ACC, then this exam that you're about to take can count as a TSIA2 exemption for math, meaning if you pass this test with a 70% or higher, then you do not have to take the TSIA2. Again, this only applies if you're going to ACC. It doesn't apply for any other school. That's enough of that. I really want to just jump into the problems here and start working these because there are quite a few. There's 50 questions here, and so it might take a little while to get through these. But I want to make sure that I go through each problem here to explain each step on how you solve these, because if you're here watching the videos, that's what you're here for. You're not here for me to just tell you the answers. You're here to find out how do you work these problems. Now, the best way that you can utilize this video is to first try to work as many of these problems as you can on your own, and then come back and any of the ones that you weren't sure how to work out, just skip forward to those problems specifically. I don't really think you need to watch this whole video, especially if there's problems on here that you know how to do. Don't waste your time. Just focus in on the ones that you are struggling with. The review that I gave you came with a key, so hopefully you're checking your answers. And if you go through a few questions and you got them all right, again, don't waste your time kind of going back and reviewing those. If you know how to do them, you know how to do them. And we're only going to focus on the ones that you are struggling with. That's enough of an intro. Let's go ahead and jump into number one. Problems 1 through 7 are all solving linear equations here, and so we just want to go through. Mostly we're just going to be using properties of equality to solve this, but we're also going to use the distributive property, and we're going to be combining like terms. There really shouldn't be anything too out of the ordinary with these equations. Number 1 says 4 times 2.5x minus 0.5 equals 158. The first step that we need to do is to distribute the 4. And so we're going to do 4 times 2.5 and 4 times negative 0.5. As you're going through these problems, I would highly recommend, since you get to use a scientific calculator, is to check your arithmetic as you go. You don't want to just, do the math in your head and then, you make a small mistake and you get the problem wrong. You want to avoid those mistakes by using the calculator, even when you're pretty confident that you know what the answer is. So anyway, 4 times 2.5 is 10. So we get 10x minus half of 4 is 2. So 10x minus 2 equals 158. Once you get the equation to look like this, where you've got one term with an x, one constant, and then another constant on the other side of the equal sign, we're going to go through this two-step process, and we're going to have to do this on pretty much every time. Every problem that's a linear equation. So the first thing to do is to get rid of that constant, and so we want to do that by adding 2 to both sides. Okay, that's going to cancel that out on the left-hand side, leaving us with 10x equals 160. Now we want to undo that 10. Okay, we want x by itself. And anytime we're trying to undo anything, we want to do the inverse operation. So the inverse of multiplication is division. So we're going to divide both sides by 10 here. And we get x equals 16, which is our final answer. Now, on these solving equations problems, after you get your answer, it's always a good idea to go back and substitute that number back into x up here and throw the whole equation into a calculator and make sure that does equal 158. I just want to suggest that you do that on every single problem just so that you can rest assured that you got it right. It's always good to have a high degree of confidence that your answer is right, so you're not second guessing yourself as you go through the rest of the test. For number 2, we need to collect all of our x terms on one side. So basically what we're going to do is we're going to move the x's to the left, and we can do that by subtracting 3x from both sides. And then we want to also collect our constants on the right-hand side. So we've got a plus 2 over there on the left-hand side. We want to move that over to the right-hand side, so we're going to subtract 2 from both sides. Now, 6x minus 3x is 3x. 2 minus 2 is 0, and that is intentional. That's why we subtracted 2 to begin with, is to get rid of it on that side. So 3x minus 3x, that's 0 as well. 8 minus 2 is 6. Then after you collect your like terms, you can then divide both sides by 3, and we get our final answer here, which is x equals 2. Number 3, now here we've got some fractions to worry about, but since you get to use a scientific calculator, don't worry, just make sure you type this in correctly. The TI-30XSs that we've got here on campus can handle fractions for you, so we've used those all year, so you know how to input a fraction. But yeah, so we're going to first use the distributive property and distribute the 1/4, distribute the 1/2. 1/4 of 4 is 1, so we have 1x plus 1/4 of 16 is 4, and then we have 1/2 of 6 is 3, and 1/2 of 8 is 4. Now we're going to combine our like terms, kind of like we did in number 2. We're going to try to knock out 2 steps at once here. First, we're going to move that 3x over to the left-hand side. You always want to get your x's to the left, and then we're going to move the constants to the right. So I'm going to subtract 4 from both sides to get rid of this 4 over here. So x minus 3x is going to be negative 2x. 4 minus 4 is 0. 3x minus 3x is 0. Negative 4 minus 4 is negative 8. Finally, we want to divide both sides by negative 2. And that's going to give us x equals 4, which is our final answer. Number 4 is going to be worked similarly to number 3. We're going to start by using the distributive property and multiplying that 0.25, which is actually just 1/4. But you're using a calculator, so you don't really even need to make that connection, although you might recognize that just by looking at that. It's a pretty common fraction there. So 1/4 of 40 is 10, so we've got 10x plus 1/4 of 24 is 6 equals 3x plus 20. Now, I know I'm doing the arithmetic in my head. I'm doing the exact opposite of what I told you not to do. But I just want to reemphasize that any arithmetic that you have to do, like 0.25 times 24, don't try to do that in your head. Do it, use the calculator to make sure that you're getting the right answer. Next, we're going to collect our terms like we did in number 3 and number 2. We want to subtract 3x from both sides. We also are going to subtract 6 from both sides to get rid of that constant on the left. So 10x minus 3x is 7x. 6 minus 6 is 0. 3x minus 3x is 0. And then we've got 20 minus 6, which is 14. Divide both sides by 7. And we get our final answer here, x equals 2. Number 5. We're going to start with the distributive property. Notice that we're always using the distributive property first. That is always going to be our first step. And then we're going to combine any like terms that we have, move all the constants to the right and the variables to the left, and just kind of go through that same process that we've been going. Now here, we do have some like terms on the same side of the equal sign, so we're going to have to combine those. Let's do that first. Negative 18 minus 4 is negative 22. So I'm going to rewrite this as 30x minus 22 equals 3x plus 5. And now I can approach the rest of this problem like I did the last few, which is to move the linear terms, in other words, the terms that have an x over to the left, and move the constants, in other words, the terms that do not have an x over to the right. 30 minus 3 is 27, so we get 27x equals 5 plus 22 is 27. And if I divide both sides by 27, I'll get my final answer, which is x equals 1. Number 6, start with the distributive property once again. Multiply both of these by 0.2. We've got 0.3x plus 0.2x plus 0.2 times 30. This is going to be something that you're going to want to throw into the calculator, but it's 6. Then we're going to combine our like terms. 0.3x plus 0.2x is 0.5x. So 0.5x plus 6 equals 4. Now we're going to subtract 6 from both sides to get 0.5x equals negative 2. And finally, we're going to divide both sides by 1/2 here, which is 0.5. And so I get x equals negative 4. Number 7, 7x plus 5 equals 3x minus 7. Here, there's no distributive property because there are no parentheses. So we're just going to start by moving over the 3x to the left-hand side, but also moving that 5 over to the right-hand side. So I have 4x equals negative 12. Dividing both sides by 4 is going to give me my answer, which is negative 3. Okay, let's move on to some percent questions. That's enough solving linear equations. So here we go. We got a couple of percent questions. 8 says, after eating dinner with a group of friends, the bill totals $67.50. If the group wants to leave a 20% tip, how much is the tip? So basically what we're trying to compute here, and on any of these word problems that have to do with percents, you really want to try to simplify what the question's asking, and it will make finding the answer a little bit easier. So what we're trying to find, so we want to know what is 20% of 6750. Now 20%, a percent is a number out of 100. So 20% is 20 over 100, or 0.2. Of can be interpreted as multiplication in this context, and then 6750. So this is going to be something you just type in the calculator, 0.2 times 6750, and you get $13.50. Number 9 says Kamari, I'm not sure how you pronounce that, but they earn 7% commission on her weekly sales. Last week, she made $5,980 in sales. How much commission did she earn? So what we want to know is what is 7% of 5,980? So 7% as a fraction is 7 over 100, or you could write it as a decimal as 0.07. Of is multiplication. So we're going to multiply 0.07 times 5,980, and we get $418.60. Make sure when you're writing these dollar amounts, both of these really only had one decimal point or decimal place after the decimal. But make sure you put that second one when we're talking about dollar amounts, because usually when you report a dollar amount, you have 2 decimal places worth of accuracy, even if that last decimal is a 0. Number 10 says Sydney wants to buy a shirt for $17. Sales tax in her city is 8%. How much does Sydney have to pay for the shirt, including tax? So here, not only do we need to know what is 8% of 17, but the total amount is going to have us put those together. So we're going to have the original cost plus the tax, right? So the original is 17 plus the tax, which is 8% of 17. So we've got 17 plus 8 out of 100, which is 0.08, times 17. And that's going to give us our total amount. So that 0.08 times 17 is $1.36. So we have the original amount plus $1.36. And so our total amount will be $18.36. Okay, that's the original amount plus the tax. Number 11, Cameron has a salary of $1,560 per month. He budgets $468 a month for his savings. What percentage of his monthly budget is his savings? So this is a percent question, but it's going to be formatted a little differently than some of the other ones. We're not just calculating like what is the percent, what is, say 10% of this. We want to know what actually is the percent. So the question we're asking is 468 is what percent of 1,560? Okay, so 468 is equals what percent, so some number out of 100 of 1560. So this is our setup, and we're going to solve this like a linear equation, kind of like how we did the first, 7 problems. First, we're going to divide both sides by 1560, and I'm not even going to do the arithmetic here. I'm just going to leave it as a fraction. So we have 468 divided by 1,560 equals x over 100, and then we just need to multiply both sides by 100. And this is something that you can just throw in the calculator. You're just going to type in 100 times, maybe I'll just write it out here, 100 times 468 over 1,560. And this is going to give you a percent, so you're not going to have to convert this because we already set it up as a number out of 100. So it's 100 times 468 over 1,560, which is 30. So 30%. Number 12, Amaya's wages are $3,300 plus 4% commission on monthly sales. A says, write a function that expresses the relationship between Amaya's wages W and her monthly sales S. So there's not really any work to show here. It's just a matter of making sure that we're interpreting the question correctly. So the wages W are going to depend on her monthly sales. So our dependent variable is W. So W equals the $3,300 that Amaya is guaranteed on the month, but then plus the 4% commission. So that's going to be 0.04, or if you want to write it as a fraction, 4 out of 100 times the total sales. So that's it. It's just looking for that equation. Then part B says, how much did Amaya sell this month if her paycheck was $3,633? So this is going to be a W value. That is the her wages. So we're going to plug that into W. 3,633 equals 3,300 plus 0.04 S, and we're going to solve for S. So this is a two-step equation. We're going to start by subtracting 3,300 from both sides. Okay, and you really don't even need a calculator for this, but I would still advise you to throw it in there just to be on the safe side. We get 333 equals 400ths S, and then we want to divide both sides by that 400ths. Okay, I guess kind of run out of room here, so I'm just going to draw a little arrow. So 333 divided by 0.04 is 8,325. Okay, so those are her sales. Okay, that's how much did she sell that month. Number 13 says Antonio drove 434 miles for a business trip. It took him 7 hours to arrive at his destination. What was his average speed in miles per hour? Okay, so we're looking for a speed in miles per hour. Now, to be able to answer this, sometimes it's helpful to remember this little formula. Distance equals rate times time. Okay, so D is distance, R is rate, and T is time. You don't necessarily have to memorize this to get this question right, but I just find on any of these questions that are relating a distance to a speed or anything like that, it's really helpful to just kind of have that formula at the ready. And this is not going to be a formula that's given to you, so you should just memorize it. It's not really that terrible anyway. I mean, it's literally just 3 letters, but and you could just remember dirt, right? DRT. Okay, so anyway, he drove 434 miles. That's a distance. Took him 7 hours. That's a time. So we want to know what's the average speed. That's a rate. So if our setup is distance equals rate times time, and the distance is 434, the rate is what we're trying to solve for, and the time is 7, all you need to do here is just divide both sides by 7 and have your answer. So 434 divided by 7 is 62. So we can say that the rate is 62 miles per hour. Number 14 says Caitlin had a full tank of gas before she left for her trip. She traveled 204 miles in total. At the end of her trip, she filled up her gas tank, which cost her $17.64 for 6 gallons of gas. Part A says, what is the price of gasoline in dollars per gallon? So here we're going to set up a little proportion here. If 6 gallons cost $17.34, then we want to know how much is 1 gallon. And so to solve a proportion, you're just going to cross multiply. 6 times x is 6x. 1 times 1734 is 1734. And then you're going to divide both sides by 6. Now this proportion is set up so that you don't really even have to go through this proportion method. If you just realize that 6 gallons of gas costs $17.34, you can simply just divide that cost by 6 to get 1 gallon of gas. That's what we're doing here algebraically anyway, but you might be able to just handle that reasoning without actually going through this proportion here. Anyway, when we divide by 6, we get $2.89. So that's the cost, gasoline, in dollars per gallon. What is the fuel consumption in miles per gallon? Okay, so we want miles per gallon. Okay, now she traveled 204 miles in total and used 6 gallons of gas. So that's basically it. We're just going to divide here. 204 divided by 6 is 34. So 34 miles per gallon. Number 15 says if y varies directly with x and y equals 24 when x equals 8, find x when y equals 18. Well, here we need to set up an equation. If y varies directly with x, what that means is y is proportional to x. In other words, there's some proportionality constant, which I'll call k, that you can multiply by x to get y. And so what we need to do is use the given piece of information here, which is that y is 24 when x is 8, to figure out what that k is, and then we can reset up the equation with the k in there to answer the question. So if y is 24, when x is 8, if we divide both sides by 8 here, 24 divided by 8 gives me 3. So I know that my proportionality constant is 3, and I can set up my equation here. Y equals 3x. So it says find x when y is 18. So if y is 18 and we divide both sides by 3, 18 divided by 3 is, 6. So we get 6. So really just make sure you know what it means to vary directly. It just means that those two variables are related, they're proportional. Number 16 says the mass of a liquid varies directly. Again, varies directly. So we're going to set up an equation like y equals kx with the volume. So anyway, the mass is proportional to the volume. Okay, so I'm just going to use m and v here instead of x and y. If a liquid has a mass of 11 kilograms and a volume of 5 liters, okay, so that's our given information. We're going to use that information to solve for that proportionality constant. So the mass is 11 when the volume is 5. If I divide both sides by 5, 11 divided by 5 is 2.2. So that's my proportionality constant. And now I can set up my equation. M equals 2.2V. So it says, what is the volume of the same liquid if the mass is 33 kilograms? So here, if I plug in 33 for M, now that I know my proportionality constant, all I need to do is just divide both sides by 2.2. And I'm going to get my volume. 33 divided by 2.2 is 15. So 15, what are our units here? Liters. Number 17 says Matthew is painting a wooden fence. 1 can of paint can paint 42 wooden boards of the fence. How many cans of paint does Matthew need to paint 147 wooden boards? So here we're just going to set up a proportion. You can solve it similarly to how we did these other two. But I really like setting up the proportions because then you can kind of visually see exactly what is relating to what here. So it says 1 can of paint. So I'll just say 1 can of paint can do 42 wooden boards. Okay, so how many cans of paint do we need for 147 wooden boards? And so when you set up this proportion, as long as you know how to use the cross products property, otherwise known as cross multiplication, really hard to get this problem wrong. So 1 times 147 is 147. X times 42 is 42x. And so if I want to know how many cans of paint, that's going to be our x. We're just going to divide both sides by 42. So 147 divided by 42 is 3.5. So 3.5 cans of paint. Number 18. Daniela's fish tank has cloudy water. Poor fish. To make the water clear, she can add 4 milliliters of cleaner for every 10 gallons of water. Okay, so that's a little relationship we got there. 4 milliliters of cleaner for every 10 gallons of water. How many milliliters of cleaner does she need to add if she's got 15 gallons of water? So here, the proportion that we're going to have is going to relate the milliliters of cleaner, which is 4, to number of gallons of water. Okay, and so we want to know how many milliliters of cleaner does she need if she has 15 gallons of water. So here we're just going to, again, use the cross products property. Do 15 times 4 equals 10 times x. 15 times 4 is 60. So if we divide both sides by 10, we're going to get 6. And our units here is milliliters. Number 19, 1 serving of milk has 73 calories. How many calories are in a bottle of milk if there are 4 servings per bottle? Now, you might be able to just read this and realize that all you have to do is just multiply these both by 4. I think setting this up as a proportion or an equation and solving is kind of overkill because they do, I don't know, it just sounds kind of simple. But I'm going to go through it anyway. But just know that on this one, all you're going to do is just multiply 73 times 4. So we have 73 calories for 1 serving of milk. So 1 serving of milk is the same. It has 73 calories. And so we want to know how many calories. So it's going to be X calories if there are 4 servings. So I don't really need to write those units again. Let's just write it like that. So here, if we use the cross products property, we're going to have x times 1, which is just x, equals 4 times 73. And so you can see how the algebra works out to be what you may have already kind of figured out, which is you just need to multiply 73 times 4. So 73 times 4 is 292. So you have 292 calories. Number 20, gas is $2.72 per gallon. Wait a minute, I think I said that wrong. $2.72 per gallon. How much does it cost to fill a 13-gallon tank? Again, you could probably just reason that, hey, I just need to multiply $2.72 by 13. That is totally correct. If you're looking to see how that works as a proportion, it's 1 gallon costs $2.72. So we want to know if you've got 13 gallons, how much does it cost? So at 1 times x is x, and we're 13 times 2.72. So yeah, again, you're just going to multiply those two numbers together. 13 times 2.72 is $35.36. Okay, for 21 through 26, we are factoring the following expressions. And so to factor, if you've got a quadratic trinomial like number 21, then all you really need to do is find two numbers that multiply to give you 30 and add up to 13. So they need to, in class, we didn't really do a whole lot of factoring, but this was covered back in Algebra 1 and Algebra 2. We want to find two numbers that multiply to give me 30, but add up to give me 13. Okay, now it might take you a little bit of time to kind of come up with those. Probably the easiest way, I think, is to just find two numbers that define all your factors of 30, which would be like 1 and 30, 2 and 15, 10 and 5, 10 and 3, etc., and just come up, like make that list, and then come up with, which combination of factors adds up to 13. This one works out to be pretty simple. It's just going to be 10 and 3. Just showing my work over here. There's not really a whole lot of work to show here. Our factors are going to be x plus 10 and x plus 3. Now, if you're ever not sure whether or not you did it right, you could always check your answer. I'm going to box my answer here because I know it's right, but you could check by simply multiplying these two binomials together using FOIL or the distributive property, or however you were taught how to multiply these together. Maybe use the box method, but basically we're going to use the distributive property. X times x is x squared, x times 3 is 3x, 10 times x is 10x, and 10 times 3 is 30. If we combine our like terms, we get x squared plus 13x plus 30, which was the original problem. So you can always go back and check your answer on these factoring problems if you're not sure if you got it right. Number 22, the first thing I noticed about this one is that the quadratic is not set up in standard form. So we need to, I'm going to rewrite this just to make it a little easier to work with as 2y squared minus 15y plus 18. Now, the last problem had the leading coefficient as a 1. There was no number in front of the x squared, and so we can kind of take a shortcut for the factoring. But if you have a leading coefficient that's not 1, I would recommend that you factor by grouping. There are many methods for factoring, and if you know a different method, I would just say stick to what you know, whether it be reverse box method or just kind of guessing and checking. All those are fine, but I'm going to go through the steps for factoring by grouping, which works for all these cubic trinomials, whether or not that leading coefficient is 1. Just know that if that leading coefficient is 1, you can take the shortcut like we did in number 21. So the factoring by grouping method, basically the idea is we want to split up this middle term into a sum of two terms that could be used to factor a GCF out of each group, being the first two terms and the last two terms. So the first step is you're going to split up this into basically a sum of two binomials, where the first term is just simply the same as the first term, the 2y squared. The last term is the same as the last term, which is 18. And so what we want is a specific way of splitting up that middle term so this whole process works. And so to do that, you're going to find two numbers that multiply to give you the product of A and C here. So 2 times 18 is 36. And so we're looking for two numbers that multiply to give me 36 and add up to that middle term, which is negative 15. Okay, so this is, A times C, and that's just B. So notice how you kind of do the same thing as you did on the easy one, but you just can't take a shortcut here. So two numbers that multiply to give me 36 and add up to negative 15. Well, they both have to be negative if they're going to multiply to give me a positive and add up to a negative. So we're looking for two negative numbers, and those are going to be negative 12 and negative 3. So that's going to be how I split up that negative 15. Okay, negative 12x, or not x, because it's in terms of y here. Sorry, negative 12y and negative 3y. Okay, so that's the first step, is to split this up and group the first two terms and the last two terms. So that's kind of where part of this name comes from, factoring by grouping. So we've grouped them up. Now we're going to do the factoring part. So the next step is going to be to factor out the GCF, or the greatest common factor, out of each group. So out of the first group, the greatest common factor is 2y. So I'm going to factor out a 2y, which will leave me with y minus 6. And then on the second group, I can factor out a negative 3. So minus 3 times y minus 6. Now, at this step, you kind of want to stop and make sure that you're doing it correctly. And you'll know that you're doing it correctly if the two expressions on the inside of the parentheses are the same. If that's the case, that's sort of your green flag to say, hey, you're ready to continue on. You did it right. If those two expressions are different, then you can go back and kind of review your work to see kind of where you went wrong. One common place to kind of go wrong here is just make sure that when you're factoring out the GCFs, like on this second binomial, that you always want a binomial that has a positive leading coefficient. So, oftentimes students will just factor out a positive 3 here and say plus 3, and then have like a negative y plus 6, which would not be exactly the same as the other one. But then it shouldn't be too hard to figure out what you need to do there to kind of change it so that what's inside those two sets of parentheses are the same. So if they are the same, which they are here, then you know you're doing it correctly. And so your first factor is going to be that factor that is common to both of them. And then the second factor is going to be the terms that are left over. So the 2y minus 3. Now, the reason why those two expressions are the same is because basically what you're doing is you're actually factoring another GCF, or at least it's kind of like factoring a GCF, whereas the GCF, or that common factor to both terms, is the y minus 6. So it's like you're pulling this out like a GCF, and it's just going to leave you with the 2y minus 3. So yeah, those are our two factors here. So yeah, factoring a trinomial can be easy if the leading coefficient's 1, or can be a little bit more challenging when the leading coefficient isn't 1. Just make sure you're not taking shortcuts where you're not allowed to. You don't have to ever take a shortcut. You can work all factoring problems with this factoring by grouping as long as it's trinomial. Even if it's not, you can kind of get away with doing it. But if that leading coefficient is 1, just make sure you're doing the shortcut. It's just so much easier, and you can skip a lot of those steps. Okay, number 23, we've got another trinomial. So we're going to work this out basically the same way as we did the last one. We're going. Oh, geez, this one's kind of definitely going to want a calculator here. We're going to start by writing the first term as 3x squared. The last term is minus 56. But we need to come up with two numbers that multiply. I'm going to throw this in the calculator. 3 times negative 56 is negative 168. Right? This is A times C. So that's negative 168. And then they need to add up to 13. Now, when your number is really big like this, you're going to have a calculator. So just start. I mean, honestly, it's a little bit of guess and check here. You just start dividing that 168 by different numbers and hope that you can come up with a factor pair that adds up to 13. Now, the 168 is negative and the 13 is positive. And since our product is negative and our sum is positive here, that means that one of the two numbers is going to be negative and one of the two numbers is going to be positive. Since your sum is positive, that means the bigger of the two numbers is going to be positive. So I'm just going to kind of go through and say, okay, well, what's 168 divided by 2? That's a good starting place. That's 84. That doesn't have a difference of 13, so that's not really going to do anything for us. 168 divided by 2 is 84. That's not very helpful. Let's see, divide by 4. 168 divided by 4 is 42. Okay, not really helpful. We're looking for a difference. That's 13. 168 divided by, let's say, 8 is 21. Okay, that actually, is that going to be it? If, let's say, 8 was negative, then 21 minus 8 is 13. Okay, so that's going to be our little combination there. So we got 21 and negative 8. And sometimes it's easier to put the negative number first. That way you don't have to remember to factor out a negative number out of your binomial, your little group there. So the way we're going to split up this 13x is we're going to write minus 8x plus 21, okay? And the factoring by grouping technique has us grouping up the first two terms and the last two terms, and then we'll factor out the GCF out of each one. The GCF out of the first one is just simply x. So we've got 3x minus 8, and that's kind of a little clue. I forgot the x on that other term as far as what we should be factoring out on the next one, because we're looking for what's inside the parentheses to be the exact same. So if I factor out a 7 here, let's see, I'm pretty sure 56 divided by 7 is going to give us 8, but let me just double check. Yep, okay, so 7 times 3x minus 8. Here we're going to check to see if we're ready to continue, and our check is that what's inside the parentheses here is the same thing, which it is. So we're good to write our two factors, which are going to be 3x minus 8 and x plus 7. Okay, now 24. This is a factoring problem, but it's actually a special case of factoring called a difference of two squares. Okay, so basically anytime you've got an expression that's written in the form a squared minus b squared, you can factor that out as a plus b times a minus b, where a and b are the square roots of the two terms in the difference of two squares. So this is just a quick shortcut here. You don't have to do any x method, no factoring by grouping or anything. The square root of 36 is 6, so we just have c plus 6 times c minus 6. You really want to be on the lookout for these difference of two squares problems, because they are super easy, and as long as you know what to do, there's not really any work to show there. 25 is another difference of two squares problem. We have 4x squared minus 64, so the square root of 4x squared is 2x, so we have 2x, and the square root of 64 is 8, so we have 2x plus 8 times 2x minus 8. Now, one other thing I suppose you could do here is you could factor out a 2 out of each one of these, like factor out a 2 as a GCF here, also a 2 as a GCF here, and then 2 times 2 is 4. So you could write this as 4 times x plus 4 times x minus 4. Technically, that would be the most simplified you could get, although I'm pretty happy if you get this far. If you recognize that's a difference of two squares, then you're good to go. One other thing that you could have done is, if you recognize you've got that GCF from the beginning, is you could have factored out the 4 as a GCF up front. So if I factor out that 4, that leaves me with x squared minus 16, which it might be a little easier to see the difference of two squares there. The square root of 16 is 4, so we still get x plus 4 times x minus 4. So this is just an alternate way of how you're going to get there, but either way, that's your answer. Number 26, we do have another quadratic here, which some relatively big numbers. I don't know why they're giving us such big numbers. I guess because we get to use a calculator, it's not that big a deal. But I always find these kind of problems a little annoying. 15x squared is going to be our first term, minus 24 is our last term, and so we need to break up that 2x. So I'm going to just set up a little x method here. So we want two numbers that multiply to 15 times negative 24. That's negative 360. And they need to add up to the b term, or the b coefficient, which is 2. So we're looking for two factors of 360. Now the product here is negative, so one's going to be positive, one's going to be negative. The sum is positive 2, so that means the larger of the two numbers is positive. And they should be pretty close together because, you know, the sum is 2. So that means that like one has got to be two numbers bigger than the other one, since one of them is going to be negative. So it's like, I know that 36 and 10 isn't going to work right off the top because the difference between them is not 2. So it's going to have to be numbers that are a little closer together. So I'm going to try 360 divided by, I don't know, 18. It seems like that is really the only thing that could work, and sure enough, that's true. So we're going to have 20, and we're going to have negative 18. I'm going to put the negative 1 first just to make the whole process a little simpler here. So yeah, we've got minus 18x plus 20x, and now we're ready to group and factor out the GCFs. So the GCF of the first one is 3x. So we have 3x times 5x minus 6. And then the GCF of the second one, what would that be? I guess that would be 4. So, and again, we get 5x minus 6. Here we're going to just take a moment to check the two parentheses that they're the same, and sure enough they are. So my two factors are going to be 5x minus 6 and 3x plus 4. Okay. Number 27 says Rudy was visiting the United States and he saw that the temperature in Cincinnati was 14 degrees Fahrenheit. Solve for C in the formula F equals 9/5 C plus 32 to find the Celsius temperature. Okay, so they give us this formula, they give us the Fahrenheit, and we just have to solve for C. So we have 14 equals 9/5 C plus 32. The first step is going to be to subtract 32 from both sides. So 14 minus 32 is negative 18. So negative 18 equals 9/5 times C. Now, the following step, if you're doing this by hand, I would say split this up into 2 steps. But because you get a calculator that can handle fractions really nicely, I'm just going to say, hey, go ahead and just divide both sides by 9/5. And let me know if you're having any issues typing that in, or if you just can't figure out how to type in a fraction. It's actually pretty easy with the calculators you're going to be using. So hopefully it's not a big deal because we've been doing this all year. But yeah, just want to type in negative 18 divided by 9/5, and we get negative 10. So C is negative 10 degrees Celsius. Number 28 says a catering company determines the cost of providing food for an event with the equation C equals 9P plus 285, with P being the number of people attending the event. Part A says, what is the cost of catering if there are 726 people attending the event? So this number is the total number of people. That's what we're going to plug in right there for P rather. We're going to solve for C, which is the cost. So C is 9 times 726 plus 285. There's no algebra to do here, nothing you need to solve. You just need to type that in. Hopefully you're able to type that into the calculator correctly. And I'm getting a cost of $6,819. Part B says, how many people attended if the cost was $1,563? So here they're giving you the cost, and you have to find the number of people that attended. In this case, you will have to do a little solving because the variable that you're trying to find is not already isolated. So the first step in this 2-step equation is going to be to subtract 285 from both sides. 1,563 minus 285 is 1,278. Then we're going to divide both sides by 9 to get our answer here. P is, and I'm just going to type this in over to the side here, 142 people. Number 29. In 2013, a couple rented an apartment for $990. Each year, the price of rent increased by $35. So let's try to start. Let's write a little expression here to represent the total price. So the price, which I'll just call it price right now, equals 990 plus 35 times the number of years. Okay, so maybe we can write this using variables. P equals 990 plus 35 times T for time. So it says, how much was rent in 2017? So from 2013 to 2017, there are 4 years in between those 2 years. So that's going to be our T. So T is 4. So our price is going to be 990 plus 35 times 4 years. And that is $1,130. Next, it says, in what year will rent reach $1,305? Now, you could just keep adding 35 until you get there, but it might be a little faster to just plug that into your price equation. 1,305 equals 990 plus 35t. Now you want to be a little careful here. This is going to give us the number of years since 2013. We are going to have to find the actual year by adding that back to 2013. So first, we're going to subtract 990. 1305 minus 990 is 315. So we have 315 equals 35t. So that looks pretty ugly there. Let me make sure that looks like a t. Okay. Next, we're going to divide both sides by 35. So 315 divided by 35 is 9. So it's going to be 9 years, but that's not really the answer that we're looking for. It says in what year will that happen? So 2013 plus 9 is in the year 2022. All right, starting with number 30, we're going to solve some inequalities. Now, inequalities are solved basically the same way that you solve an equation. So back on problems 1 through 7, we went through several solving equations, linear equations. All those same steps are going to be valid here too. Really, the only difference here is that when you're solving an inequality, anytime you multiply or divide both sides of the inequality by a negative, you do have to flip the sign. So with number 30, we're going to subtract 2/5 from both sides. And this is just something I'm going to throw in the calculator here. I'm not going to bother trying to do the arithmetic by hand. 7 minus 2/5 is 33/5. So C is less than or equal to 33/5. Number 31. First, we'll subtract 3 from both sides. And we get negative 5x is greater than a negative 35. Then we're going to divide both sides by negative 5. Now, this is where, put a little star here. This is the only place where solving an inequality is different than solving an equation. Is anytime you multiply, I'm going to actually write this out. Anytime you multiply or divide both sides of an inequality by a negative, make sure you flip the sign. In other words, change it from greater than to less than. So negative 35 divided by negative 5 is 7. But because we're dividing by a negative, we do need to flip this inequality symbol. So we get x is less than 7. So you really want to make sure you're careful with those inequalities. Number 32, we'll start by subtracting 7 from both sides, giving me 6y is greater than or equal to negative 36. Then we're going to divide both sides by 6. Now, even though the negative 36 is negative, we are dividing by a positive number. We're dividing by positive 6. So nothing's going to change as far as our inequality symbol is going to go. So we get y is greater than or equal to negative 6. On number 33, I'm going to distribute that negative 3 to give me negative 3x minus 5. Oh, wait, hold up. Nope. Minus 45 is less than 6. Then I'm going to add 45 to both sides, which gives me negative 3x is less than 51. Finally, I'm going to divide both sides by negative 3. And since I am dividing by a negative 3, make sure to flip that sign. So I get x is greater than 51 divided by negative 3 is negative 17. Okay, number 34. First, we'll use the distributive property on both sides here. So I get 2t minus 12 is greater than 7t plus 28. Then I'm going to move my linear terms to the left-hand side. So I'm going to subtract 7t from both sides, but I'm also going to move my constants to the right. So I'm going to add 12 to both sides. 2 minus 7 is negative 5, so I get negative 5t is greater than 28 plus 12 is 40. Next, I'm going to divide both sides by negative 5, and hopefully you're going to catch this, that when you divide by a negative, you do have to flip the sign. I've seen a couple problems like that so far, so hopefully you're starting to put that together. So we get t is less than negative 8. All right, let's change gears here a little bit. Start talking about some graphing of linear functions, slope, y-intercept, all that good stuff. And we'll start with number 35. This problem is giving us a linear equation that's actually in standard form and is asking for the slope and the y-intercept of this function. So the easiest thing to do here is to try to manipulate this equation into slope-intercept form, which is the form that you're probably the most familiar with going years back, y equals mx plus b. If you can get it in this form, then you can easily identify the slope and the y-intercept because the slope is m and the y-intercept is b. So what we need to do is we need to take this equation, 2x minus 5y equals 45, and try to get it into that form. The first step to do that is going to be to move that 2x over to the right-hand side. We could do that by subtracting 2x from both sides. And that'll give me negative 5y equals, and you can write this as 45 minus 2x, but notice how on our template over here for slope-intercept form, we have the term that has the x, or that linear term, coming first. So I'm going to actually write this as negative 2x plus 45. Then next, we want to divide both sides by that negative 5. Make sure you divide every term on the right-hand side by that negative 5. And we should end up with y equals negative 2 over negative 5. That doesn't reduce, but they're both negatives, and a negative divided by a negative is positive. So we can just write this as 2/5 x, and then 45 divided by negative 5 is negative 9. So now we have it in that form, and we can see that the slope is 2/5, and the y-intercept is negative 9. Now, the y-intercept is a coordinate on the plane, so it's probably best that we write it as a coordinate pair here with an x-coordinate and a y-coordinate, 0, negative 9. Number 36 wants us to graph that equation, and if we have the slope and the y-intercept, it really shouldn't be that big of a problem. We can start by plotting the y-intercept, which is at 0, negative 9. And is this even going to fit? Let's see. 1, 2, 3, 4, 5, 6, 7. Okay, nope. 8, 9 is going to be like down here. So this is at negative 9. And then the slope is 2. So we're going to go up 2 over 5. So this slope is the rate of change of the function. And one way you can interpret slope is as rise over run. So we're going to rise 2, run 5. 1, 2, 3, 4, 5. Plot that point. Yeah, unfortunately, this grid doesn't really, there's not going to be much of the line on the grid at all, but it's going to be kind of down here. I suppose you could rescale this and have each of those units be 2 units instead of 1, but I'm just going to let it be as it is. Number 37 says, what is the slope between the points negative 5, 15, and negative 2, 4? Now, if you have a grid that's big enough to plot both of those 2 points, you can go ahead and plot those and then just find your rise over run with the grid. But finding slope is actually not as hard as you might think. Okay, the classic slope formula, y2 minus y1 over x2 minus x1, I think does kind of a disservice to really having a deeper understanding of what slope or rate of change is, which is really the change in the y value divided by the change in the x value. So I'm going to actually rewrite this as delta y over delta x. And mathematics, when you use the Greek letter delta, typically it's used to represent change. So I'm saying the change in y over the change in x. Now, I think when we think about it that way, it becomes a little bit easier to compute the y2 minus y1 when you're not really just trying to plug in all those numbers and hope that it works out. And you definitely can do that. But the process I like to suggest here is just to write out the 2 points, find your change in y, which is the change in the y values, right? Here's my change in y, and then also the change in x, okay? So the change in y, how do I get from 15 to 4? Well, I have to subtract 11. And then how do I get from -5 to -2? Well, I have to add 3. And so my change in y is -11. My change in x is +3. So my slope is -11/3. Now, you could also just plug in these coordinates into the classic slope formula. Again, this is just the algebraic representation of rise over run. But then you have to make sure, okay, this is x1, y1, x2, y2. Make sure you plug everything in and have your parentheses set up. Sometimes you get a minus negative. I just think that it's a little bit easier to think about it in terms of change in y over change in x. But there's like I said, there's a few different ways you could approach that. Number 18. 38 says, write the slope-intercept form of the equation for the line containing the points -3, 1, and -2, -5. So we're going to find the slope the same way that we found the other one, but we're not going to have the y-intercept, at least not at the beginning. So what we'll have to do is actually write the equation in point-slope form first, because we won't know the y-intercept. Point slope form is y minus y1 equals m times x minus x1, and then we'll try to we'll plug in everything we find there, and then try to manipulate that equation to get it back in that y equals mx plus b form. So to find the slope, okay, remember that's change in y over change in x. That's going to give us our m value. That's the m represents here. It's the same m as in the y equals mx plus b. So let's take a look at our change in y's. Oops. The y value goes from 1 to -5. Okay, so my change in y is -6. Okay, I have to subtract 6 from 1 to get to -5. And then my change in x, my delta x here, from -3 to -2, I have to add 1. So my slope is going to be -6 over 1, or just -6. So that's the slope. I don't have the y-intercept, so I can't go straight to y equals mx plus b. But like I said earlier, we're going to plug this into point-slope form and then manipulate it. So the only thing that is really outstanding here that we haven't addressed here is the x1, y1, and what to put in those two numbers. And you can actually put either of these 2 points. It doesn't really matter which one. I like to go with the one that has the least number of negatives in there, but it doesn't really matter. You could pick any point. So I'm just going to go with the first point, -3, 1, and use that as my x1, y1. Okay, so I've got my x1, y1. I've got my slope. I'm ready to plug all this stuff in. So y minus 1 equals -6 times x, and this would be minus -3. But subtracting a -3 is equivalent to adding 3. So I'm going to just simplify it right off the bat and say +3. Okay, we're almost there. We just need to do 2 steps here to get this into slope-intercept form, which is the form that they are requesting here, slope-intercept form. That's the y equals mx plus b, the one you're probably the most familiar with. So the first step here in trying to manipulate that equation is to use the distributive property. And I get y minus 1 equals -6x minus 18. And then we'll add 1 to both sides to move that, or to isolate the y. And we'll get our final answer here, y equals -6x minus 17. Number 39 says, identify the slope and the y-intercept of the given graph. So the y-intercept is where the graph crosses, I'll say where the graph crosses the y-axis. Okay, so we can see that's right here. So the y-intercept is 0, 5. The slope is going to be your rise over run. Okay, or in other words, your change in y over change in x. And so to get from this point to the next point, my change in y, or my rise, is actually a -5. Okay, because I have to go down 5. Now my change in x, or my run, is 4. So my slope, which is delta y over delta x, or change in y over change in x, or rise over run, however you want to think about it, is going to be -5 over 4. Okay, so that's the slope and the y-intercept. Now, this doesn't actually ask you for the equation of that line, but once you have the slope and the y-intercept, it's really easy to write it. It's just y equals the slope x plus the y-intercept. It's y equals mx plus b. So it didn't ask for that one, but once you have the y-intercept and the slope, you should be able to write that equation. Okay, moving on from linear equations, and we're going back to quadratics. We did a little bit of quadratics earlier when we were factoring quadratic trinomials, but here we're more focused on the graphs of these quadratic functions. So there's two things we need to find. We need to find the vertex, and we need to find the roots. So let me just break down how to find each one of those. They're not really that bad, but you just have to know there's a little formula here to get the vertex that I don't believe will be given to you. So to find the vertex, a vertex is a coordinate. Okay, we'll call it h comma k. All right, just to kind of throw in some variables there for us to solve. Now to find the first coordinate of the vertex, the x coordinate, which we're calling h, you're going to do -b over 2a, which might look a little familiar because it is part of the quadratic equation and is related to the quadratic equation. It's the x value that splits the parabola or the graph of the quadratic function in half and goes right through the vertex. So that is the value of the axis of symmetry. You're not going to be asked about the axis of symmetry on the test. You're not going to be asked to actually graph out these parabolas. But anyway, that's how you're going to find the h. Now to find the k, you're going to plug in the h into the function. So it's going to just be f of h. So you're going to calculate h and then plug that back into x for the equation to get the k. So that's how you get the vertex. Okay, to get the roots, you're going to set the equation equal to 0 and then solve for x. So you're going to solve this function equals 0 and actually solve for x. Okay, typically you're going to get two roots. A parabola most of the time is going to cross the x-axis twice, but it is quite possible for it to never cross, or for the vertex to be on the x-axis itself, and you may just get one solution. Just to kind of think about this visually, let's say you've got just kind of a normal everyday parabola that passes through the x-axis twice. Notice here, and that's what the roots are. These values that are making the equation equal to 0. Visually, they're represented by x-intercepts. So it is possible for a parabola to cross twice. It is also possible for a parabola to cross once. Not all parabolas open up. Some of them open down. So just to give you another example here. But if the vertex is on the x-axis, then you're only going to get one root. Okay, so here we get two roots. Here we get one root. There's a little bit more to that, but we're just kind of simplifying this idea and say there's one, basically get one answer. And then it is possible to have a parabola that just straight up does not cross that x-axis, and so we'll get no roots there. Like I said, there is a little bit more to this. It's a little bit more nuanced. We're not going to get into real versus complex roots or the fundamental theorem of algebra or anything. We are just going to solve this and set these equations equal to 0 and solve and report those back as our roots. So if you've taken algebra 2 and you're thinking, wait a minute, what about multiplicities and all that? We're not even going to go there. Okay, so the first one is 2x squared plus 2x minus 4. Let's start with the vertex. Okay, when I say A, B, and C here, to find that h. What I'm talking about are the coefficients of the function. So 2 is a, 2 is b, and negative 4 is c. So to get the h of our vertex, it'll be negative b, so negative 2 over 2 times a. So negative 2 over 2 times 2 is 4, reduces to negative 1/2. Okay, and then to find the k, we're just going to plug in that negative 1/2 into x, and you will get a calculator here. So I haven't used the calculator in a few problems here, but I'm going to break it back out. You may not even need the calculator, honestly. These aren't going to be too crazy. But yeah, let me go ahead and compute this. 2 times negative 1/2 squared plus, well, 2 times negative 1/2 is just negative 1, but I'm going to type it in anyway just to be on the safe side, and then minus 4. So I'm getting negative 9/2. And you could write these as a decimal too. So the vertex is going to be negative 1/2, comma, negative 9/2. And if you want to write that as a decimal, totally fine. It's negative 0.5, comma, negative 4.5. But I'm going to leave it as a fraction just because that's what my calculator initially gave me. But again, you're totally fine writing them as decimals. Okay, so that's the vertex. Now let's find the roots. Okay, to get the roots, we're going to set the equation equal to 0, and this is where factoring is going to come in handy. Okay, first we're going to simplify this as much as we can. We really, if we can, want to get that leading coefficient to be a positive 1 so that we can take the shortcut when we use the x method to factor. So if I divide everything by 2 here, and by everything I mean every single term, I can simplify this equation to get x squared plus x minus 2 equals 0. Now this is factorable, and the leading coefficient's 1, so I don't have to do factoring by grouping. I can just do my little shortcut here where I try to find two numbers that multiply to give me negative 2, which is that c value, and that add up to positive 1. And so the two numbers where that would work would be positive 2 and negative 1. So that means those are going to be my two factors, x minus 1 times x plus 2. From here, we're going to use the zero product property. And what the zero product property says is that if a times b equals 0, then either a is 0 or b is 0. The only way to have a product that equals 0 is if one of the factors is 0. So like in this case, both these are my two factors, x minus 1 times x plus 2. Since that product is 0, at least one of those has got to be 0. So we're going to set each one equal to 0, and we will solve them independently. So for the first one, we can add 1 to both sides and get x equals 1. And for the second one, we're going to subtract 2 from both sides and get x equals negative 2. So these are our two roots. We already found our vertex, and so we've got everything we need for that problem. So for part B, we're going to do the exact same process here. We're not going to change a thing. So yeah, let's just get started. The vertex, which is negative b over 2a, comma, f of h. So we'll start with h. My a value here, be careful, is negative 1. My b value is 2, and my c value is 8. So negative b would be negative 2 over 2a, so that's 2 times negative 1. Just going to try to stay consistent with the coloring here. So negative 2 over negative 2 is positive 1. That's pretty nice. It's going to work out a lot nicer than the fraction we had before. It'll be, I kind of did that in my head, but don't be afraid to use the calculator to compute that negative 2 divided by 2 times negative 1. Now we need the y-coordinate of the vertex, which I'm calling k. So I'm going to substitute in 1 into the function. So negative 1 squared plus 2 times 1 plus 8. I got to be careful with your negative parenthesis here. We're going to square 1 and then slap on the negative sign afterwards. But If you type this in to your calculator exactly how it looks, you shouldn't really have to worry about it too much. And that's what I'm doing out here to the side. Negative 1 squared plus 2 times 1 plus 8 is 9. So my vertex is 1, 9. Okay, let's find the roots. So to find the roots, we're going to set the equation equal to 0 and then solve for x. Now, the leading coefficient here is negative 1 and not positive 1. So to change that, I'm going to divide both sides by negative 1. And so that'll give me x squared minus 2x minus 8 equals 0. And now I'm ready to factor. I've got the leading coefficient equal to 1, so I can take the shortcut here and not have to go through the whole factoring by grouping process. And I'm looking for two numbers that multiply to give me negative 8 and add up to negative 2. This one might take you a little bit more time to think of than the last one. The two numbers here are 2 and negative 4. So the factors of this quadratic would be x minus 4 times x plus 2 equals 0. Again, I'm going to use the zero product property and set each one of these equal to 0 separately. The first one, I need to add 4 to both sides. And I'll get my first root at x equals 4. And I'll get my second root by subtracting 2 from both sides on that second equation. And I get x equals negative 2. So those are my roots and the vertex. These problems take a little bit of time. You definitely have to know that vertex formula to really get that. The roots, you just have to know that you need to set the equation equal to 0. Number 41 says the height h of a ball after t seconds can be modeled by this function. Okay, what is the maximum height of the ball? So if you just kind of think about what's going on here, you're throwing a ball up. I guess you don't know if you're throwing it, but anyway, the ball starts at 160 feet. You can see that from the equation here. It goes up and it comes back down. So it's going to do something like this. And it wants to know what is the maximum height of the ball. In other words, it wants to know what is this y value here. And that is going to correspond to the vertex, like we found in the previous two problems. So to find the vertex, this h right here is going to be your negative b over 2a. And then the height of that vertex, or the y coordinate, is going to be what we get whenever we substitute that number into the function. So to calculate this, we're going to plug in whatever we get for negative b over 2a into the function for height. So let's go ahead and find that value. So negative b over 2a, where a is negative 16, b is 48, c is 160. So we have negative 48 over 2 times negative 16. And it's okay to use a calculator here. Don't be afraid. Negative 48 over 2 times negative 16 is 3/2, or 1.5. So 1.5 is going to be the time at which the ball reaches the maximum height. Now, it didn't ask us for the time, although it's quite possible the test will. It's asking us for the height of the ball. So what we need to calculate is the height at time equals 1.5. Okay, so we have negative 16 times 1.5 squared plus 48 times 1.5 plus 160. Don't waste your time trying to do this by hand. I'm not going to either. I'm just going to type this in and get my answer. And I get 196. And what are our units here? Actually, it doesn't really say. I'm just going to say feet, maybe. It's 196. I don't know if it's, am I just like missing it? Nope, I'm rereading this twice and I do not see a unit there. Usually it's feet, but don't be too stressed out about the units. The function r of x equals negative 2x squared plus 60x. It represents the daily revenue earned from selling pants at X dollars each. Find r of 15. So here is just making sure that you know how to interpret function notation. All we need to do is just plug in this 15 into both instances of x. So r of 15 is negative 2 times 15 squared plus 60 times 15. This is going to be something we just type into the calculator. Negative 2 times 15 squared plus 60 times 15 is 450. So R of 15 equals $450. And it looks like we are moving on from the quadratic functions portion of the review. Now we're going on to probability and statistics. We're going to start out with some statistics. We have a set of data here. It says during the spring semester, a student made the following quiz grades, and there's a list here. And it says, what is the mean of the test grades? So usually, there are different averages, mean, median, mode are all different averages, but in everyday language, when we speak about an average, typically we're actually talking about the mean, which is a value that's going to represent this whole group of numbers. The mean is calculated by adding up all the values and then divide by how many values there are, the number of values. Okay, so in other words, we're going to have 65 plus 74. I'm actually going to write all this out. It might take me a second to type them all into the calculator, but that's what you should be doing, is just starting to add all these up. And then how many are there? Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. Total of 9 of them, so we're going to divide by 9. Oh, looks like I left off an 8 there. Okay, I think I've got them all there. 1, 2, 3, 4, 5, 6, 7, 8, 9. So now I'm just going to take a moment to type this all in. 65 plus 74 plus 85 plus 72 plus 81 plus 87 plus 98 plus 97 plus 88. All that divided by 9, and I get 83. The median of this set of data is the middle number. So what we need to do is we need to rewrite this list, but put the numbers in order from least to greatest. So let's see, it looks like the least number is 65. I'm just going to kind of highlight these as I hit them so I don't see them again. Let's see. Looks like the next one's going to be 72. Then 74. And then I think that's all the 70s. The lowest 80 number is going to be 81. Then looks like 85. '87 and then 88. We get a 2 for 1 here. And then finally 97 and 98, and that's all of them. Okay, so what we're going to do to find the median is we're just basically going to eliminate the numbers on the outside of the data set until we get to the middle number. Okay, so we'll eliminate those two. We'll just kind of pair those up and scratch them out. And then we'll do that for the second one. And we'll do that for the third one. And we'll do it for the fourth one. And that leaves us with our middle number, 85. So the median is really easy to calculate. Just make sure you write the numbers in order. And I think doing these little slashes can help. You might have noticed I did a certain number of slashes for each number just to kind of correspond. And that way I can kind of look and make sure I'm pairing them up correctly. You don't necessarily need to do that, but I just find it helpful to keep my work organized. Number 44. So the mean weight of the dogs We talked about this on the previous mean and median problem on how you find this. We're just going to add these up and then divide by how many numbers there are. So 8 plus 45 plus 183 plus 23 plus 68 plus 92 plus 120 divided by how many there are, 1, 2, 3, 4, 5, 6, 7. And so this is just going to be something we type in the calculator. 8 plus 45 plus 183 and 23 and 68, 92 and 120, all divided by 7 is 77. For the median, we're going to put these numbers in order, starting with 8, 23, 45, 68, 92, 120, and 183. And we're going to scratch out, just like we did on problem number 42 or 43 or whichever one that was. And we get to our median, our middle number here, which is 68. Number 45 says a box contains 11 purple, 8 orange, 5 brown. Let's see if I have a brown here. That's about as close as I'm going to get. 13 blue, and 7 green markers. What is the probability of drawing a marble that is not brown? So in order to calculate probability, and we'll just like lay this out right up front, probability, you're going to divide the number of desired outcomes by the total number of outcomes. These are going to both be numbers. So if we want a marble that's not brown, we need to count up all the ones that are not brown. So we've got, let's see how many total markers are wait, are we talking about markers or marbles? I think this is supposed to be a marker. I think we've got a little typo here. Otherwise, it's just going to be 0. I don't think it's supposed to be like a trick question. Okay, what is the probability of drawing a marker that is not brown? Okay, so there are 5 brown markers out of a total of, let's see what the total is. The total is going to be 11 plus 8 plus 5 plus 13 plus 7. 11 plus 8 plus 5 plus 13 plus 7 is 44. And so if 5 of them are brown, that means that 39 of them are not brown. So we have the not brown divided by the total, and that's going to be 39 over 44. And that is the probability. Number 6 says, what's the probability to draw an orange or a blue marker? So how many orange or blue markers are there? Well, there's 8 orange and 13 blue. So that's a total of 21. So we have orange or blue over the total. Okay, we still have only 44 markers. And we have a total of 21 orange or blue markers. Letter C, if 4 purple markers are removed, what is the probability of drawing a green marker? Okay, so we're taking away 4 purple markers, which is going to reduce our total from 44 to 40. And then we still have all 7 green markers. So there's a total of 7 green markers out of 40 total markers. Number 46 says there are 43 professional athletes in a room, and all the athletes play either soccer or basketball. 25 of the athletes are soccer players. If an athlete is chosen at random, what is the probability that the athlete is a basketball player? So we're looking for the number of basketball players divided by the total number of players. Now, there are a total of 43. They tell us that. They don't tell us explicitly how many basketball players there are. But if 25 of them are soccer players, then we're going to take those away from the 43. So 43 minus those 25. 43 minus 25 is 18. So there's actually only 18 basketball players out of a total of 43. And that's it. That's our probability. Number 47 says a study tested a new allergy medicine to see if the medicine could improve allergy symptoms. Some people in the study took the allergy medicine while others took a placebo. The results of the study are displayed in the following table. Part A says, what is the probability that a person who took the placebo medicine had improvement in symptoms? Okay, so we have someone that took the placebo, and had improvement. Okay, so we want to be careful about what we say is like the desired outcomes and the total outcomes here. It says, what's the probability that a person who took the placebo? Okay, so the number of people that took the placebo, that's going to be the total. Okay, so there are a total of 443 people that took the placebo medication, and the number that had improvement, so that's really our desired, is going to be 323. Oh, nope, not 323. That says no improvement. My bad. That should be 120. Almost got that one wrong. Gotta stay sharp here. I know we're 47 questions deep, but we will finish strong here. Part B says, what is the probability that a person in the study took the allergy medicine? So this is just the total number of people in the study is going to be our total. So a person in the study, and we want to know how many of those took the allergy medicine. So those are our desired outcomes. Okay, so how many people took the allergy medicine? That's going to be a total of 490 out of the total number of people that took the whole study. So that's everybody. That's out of 933. I don't think neither one of those fractions look like they can be reduced. I don't think you have to really worry about reducing fractions on this test. Yeah, the first one definitely doesn't, and I'm just throwing these in the calculator to make sure. Yeah, neither one of these, and this is not going to be a multiple choice test anyway, so don't worry about reducing these fractions. You don't have to do that. Okay, I think that's enough of probability and statistics questions. For 48 and 49, it looks like we are solving some compound interest formula problems. This is going to be a formula that they do give you, so you do not have to memorize this. You just have to know like what all these different terms mean. So let's just summarize that real quick. The principal is the initial amount. That could be either like how much was invested or how much was taken out as a loan. The rate, we're going to write that as a decimal. The N is the number of times per year that interest is compounded. And time is the total number of years. Okay, so let's break this down. 48 says Ishan invested $7,300 into an account that earns 6% interest. Okay, so let's just start identifying some of these things. That number is going to be your principal. I'll just call it P for now, for principal. The 6% interest, that's our rate, but we want to write that as a decimal. So the rate we're going to write as 0.06. Okay, part A says how much will be the account after 10 years? So that's our T. If it's compounded twice a year, so that means our N value is 2. So for here, we're just going to like plug in all these numbers where they go and just throw the whole thing into the calculator. So our final amount is going to be the principal, which is $7,300, times 1 plus the rate, which is 0.06, divided by the number of times interest was compounded, which in this case is 2, to the power of 2 times the number of years, which is 10. So again, this is just something you're going to toss in the calculator. 7,300 times 1 plus, use that fraction button, 0.06 divided by 2, all to the power of 2 times 10. If you want to just type 20, that's fine, but you can also just write it as 2 times 10. And so our total amount here is going to be $13,184.61. Part B says how much will be in the account after 41 years. Okay, so that's a new t value if the account is compounded daily. So there are 365 days in a year, so that means our n value is 365. So our amount will equal we have the same initial investment times 1 plus the same interest rate, but the n value here is different, 365, and our t value is different. It is 41. So I'm just going to type in the exact same equation I had before, but I'm going to change those 2's to 365, and I'm going to change the 10 to 41. So this is going to give me $85,427.85. Number 49. So this is going to be another very similar problem. It says if $25,500 is put into an account that's earning 4% interest, so this is our P, that's our principal. Our rate is 0.04. How much will be in the account after 11 years, that's our T, if the interest is compounded monthly? If interest is compounded monthly, then our n value is 12. Part B is going to be the exact same scenario, but the account is compounded daily. And so if it's compounded daily, our n value is 365. Okay, so let's just set this up. The principal is 25,500 times 1 plus 0.04 over 12 to the power of 12 times 11. It's going to be set up similar to B, so I'm actually just going to try to work these out at the same time. The only difference will be my n value. So for part B, my n value is 365. But everything else should be the same. Okay, so now we just need to type that in. 25,500 times 1 plus 0.04 over 12 to the power of 12 times 11 gives me $39,565.07. For the next one, I'm going to just copy exactly what I had before, but change the 12 to 365. And for this one, I get a very similar number here, $39,593, and I guess this rounds to 8 cents. Okay, last problem, y'all. I know it's ABC, but number 50, I think, is the last one. Yep, and then it's after that is just all the solutions. So number 50 says a small college has an enrollment of 7,700 students. The table indicates the academic discipline for the students at the college. Part A says about what percentage of students are business majors? Round to the nearest percent. Okay, so we want business majors. So this is really kind of like a probability problem. Can't spell business here. So we want the number of business out of the total. That's going to give us the percent. So business major is going to be 1,594 out of the total, and it looks like the total, the total is given up here, 7,700. So we're just going to go ahead and divide those. And I get 0.207. Now, when we're writing this as a percent, we need to multiply that by 100. So we have 20.7%, which rounds up to 21%. Part B says the college wants to decrease the number of undeclared students to 3% of the student population. If the number of students enrolled stays the same, how many undeclared students need to declare their major to meet this goal? Okay, so first let's find the current undeclared percent. Okay, so kind of similar to how we solved part A, is the undeclared over the total is 344 over 7,700. So I'm going to just type that in. Then we get 0.044, which is going to be about 4%. We want to decrease that number to 3%. So what we need to do is figure out what is 3% of 7,700 students. Okay, so 3%, we're kind of going back to percent problems here, 0.03 times 7,700 is 231. That's how many students we want to get this down to. So if we have 344, well, you need to get that down to 231. We need to do 344 minus 231. That gives me 113. Now, we really didn't need to know what the original percent was. I just thought it'd be a good practice here to kind of go back and review that. So you see another example, kind of like we did A. You really just need this stuff over here on the right-hand side to be able to answer that question. Okay, one last one. Part C says the college has a goal to increase the percentage of science majors in the student body to 18%. If the number of students enrolled stays the same, how many more students would need to be science majors to meet this goal? Okay, so right now we've got 1,130 science majors. We're trying to up it to 18%. So first, let's answer the question, what is 18% of 7,700? Okay, which would be 0.18 times 7,700. So 0.18, or 18% of 7,700 is 1,386. Now currently, how many did we have? We had 1,131. So we're going to do 1,386 minus, what was it? Science. Okay, 1,130. And that gives us 256 students. All right, and that about wraps it up. This is a pretty lengthy review. I can only imagine how long this video is going to be. It's probably going to be closer to 2 hours. Gosh, I thought I was kind of shooting for 1 hour and went way past that mark, but that's all right. If you have any other questions about what's going to be on this test or about how to work any of these problems, if you want me to go into a little bit more detail or just kind of help you out in terms of the different topics that you're going to be expected to know, please reach out. I'll be happy to help you. But other than that, y'all, thanks for watching and have a great day.